And the next speaker is, thank you, Ben. And the next speaker is David Schrunk, Science of Laws Institute, and he will talk about the Planet Moon project, and probably relevant to the book. David?
Can you hear me?
Yes.
Okay, my slides, should I share my slides? Is that how this works?
Yes, please.
Sorry, I'm not finding my,
The share button is at the middle, bottom row in the middle, green.
Mine is a green arrow that says share.
yeah, that's what I'm hitting it.
I think that artificial intelligence has changed because I wasn't able to do things that I normally could do. So
I don't see my slides here. I mean, I have them.
That's scary. And we don't have anybody else's slide interfering either, so it should be yours.
Sorry, I see my slides, but and I hit the share, but
Oh, you need to select what you share. There comes a pop-up window there where you can select which screen or program you share from. Yeah.
goodbye. Apologize for this.
We have a screen at least, even if it says AOL desktop. Might be the wrong computer screen if you have more than one.
artificial intelligence is not that intelligent. What happens if you click continue?
It depends on whether it wants to sign on to the AOL desktop. Maybe you should stop sharing and try again. That's the standard Windows solution. If the car doesn't work, turn off the engine, get out, and get back in again. That seems to be the right place, at least, yes.
I have the slide in front of me.
Yeah, that works.
Are you seeing it?
Yes,
You are.
yes.
Ah.
Success!
Apologies for the delay here. All of the presentations have been great, technical, and to the point, very forward-looking. This presentation is a non-technical. It's kind of the global, from the top-down approach to where we're going with lunar exploration and advancement into space. So, Badu and I are looking at lunar lava tubes as the site for the Planet Moon project. The Planet Moon project is the idea of transforming the moon into an inhabited sister planet of the Earth, and the rationale for this and what's possible. So the goal is permanent human presence on the moon by the middle of the 21st century. And this is our next home in space. The moon is nearby, it orbits Earth. Everybody knows all these things, but I need to repeat them. It has resources that we can use. Obviously, it has gravity. You can pour liquids from one container to another on the moon. It's convenient. It's a stepping stone to space. It's nearby, and we go there first, and then we can go everywhere. What is our motivation for going to the moon? We want to preserve humanity. The Earth will not exist forever, so we have to think in terms of going off Earth and preserving humanity. It will give us access to unlimited resources of space, energy, and material resources, and we will become a spacefaring civilization using the unlimited resources of space to do big things in space, independent of Earth resources. And we can talk about beginning the grand diaspora, where we take our human culture and spread it throughout the nearby galaxy. And I have an asterisk here. The grand diaspora is to go from our planet to other regions in the galaxy, because we're assuming that we humans are a net positive force of nature. So we owe it to the rest of the our neighbors in space that we explore and extend ourselves into space. So people might argue that we're not a net positive force of nature, but that's the basis for this. The reason for going into space and setting up a second home in space has a consensus of the scientific community, intellectual and political community, the space agencies, the space advocacy associations, and the general public. So we have the motivation to go into space. What are the means we have to achieve this goal? We have the technology to do this. We have resources that we can use in space. And we've discovered lava tubes. That's the focus of this discussion. And we have the opportunity for international cooperation. So these are very powerful tools that we can use. The enabling technologies, artificial intelligence, large capacity rockets, robotics, teleoperations, communications, manufacturing, safe nuclear power. And if you look at these 20 years ago, a lot of these were relatively new. And the technology tends to grow exponentially. So 20 years from now, these will all be very mature technologies. So we can count on technology being available and growing in pace with our need to go into space. Lunar resources, we have sunlight that's inexhaustible and predictable. We have material resources in the moon. Everybody here knows what these are: oxygen, silicon, aluminum, iron, titanium. We have light element resources in the polar regions. We have water in cold traps. The L-Cross mission went into the South Polar region, and the part of the satellite was deliberately crashed into the crater on the moon, and it threw up a plume that we measured methane, methanol, ammonia, sulfur compounds, carbon dioxide, carbon monoxide in the South Polar region. So we have carbon, nitrogen, and sulfur compounds. This is not a lot. This isn't a lot or a large amount, but it is available, and we can think about exploiting that at some point in the future. The challenges: we have significant lunar surface hazards. We have temperature extremes. This is a day-night cycle of temperature on the moon. It goes from 400 degrees Kelvin to 100 degrees Kelvin, a 300 degree swing in temperature. This puts significant thermal stress on anything that's on the surface, humans in spacesuits and any kind of equipment on the surface of the moon. We have ionizing radiation. These are cosmic rays. These are atomic nuclei that come in with very high energy. We have gamma rays and X-rays, which are photon radiation and solar flares. I'd like to point out that the gamma rays, these break molecular bonds, which can repair themselves. But the atomic nuclei that come in, these destroy cells. They are you can't just repair this kind of damage from the cosmic galactic rays. These are very dangerous. The radiation on the surface of the moon is 2 orders of magnitude above what is considered safe for humans. So the lunar surface is unsafe. The idea of having people in spacesuits walking around and doing things on the moon, and it's popularly presented that way, is just not going to happen. People are going to go out on the surface of the moon in spacesuits under emergency conditions, but very rarely for anything else. The spacesuits and space cabins are both inadequate. When a cosmic galactic ray hits a space cabin, a rocket ship, the starship, it interacts with the material, the steel or aluminum shell, and it produces secondary radiation, a process called spallation. When the cosmic ray hits it, it produces secondary radiation that then acts like a shotgun of radiation to the people inside. I'd like to just point out that the starship with the steel hull is not safe. Lunar dust. This is the space weathering produces the lunar dust on the surface. This is very microscopic. It has sharp edges. It's everywhere on the surface, and it's a hazard for biological systems, for lungs. It causes pneumoconiosis and scarring of the lung. It's hazardous to skin, mucous membranes, and eyes. It's hazardous to equipment. It's abrasive, reactive, has a static cling. Lunar dust is a big hazard on the surface. It's a big showstopper. Micrometeorites are microscopic. They come into the lunar surface at tens of kilometers per second. The energy equation, 1/2 mv squared, there's a lot of energy, even though they're very tiny grains of sand. They deposit significant energy on anything they come in contact with on the lunar surface. So they're a definite hazard for spacesuits and any kind of equipment on the surface of the moon. What is the solution to these challenges of radiation, dust, and micrometeorites? One thing we can do is to dig a trench and put in inflatable habitats and cover them with several meters of regolith. And this would absorb the radiation hazards and you'd be protected from micrometeorites. The problem with inflatable habitats for an initial startup on the moon is that these are limited size, and there's a significant challenge from psychological stress from being in a habitat like this on the moon. In the Antarctic expeditions, confinement in the cabins on in the South Polar region led to significant degradation of performance. There's lack of privacy, there's noise, there's forced socialization with crew members, increased or decreased sensory input, fear of equipment failure, and so on. So even just simple tasks were very difficult to perform in Antarctica missions. So the second solution is lava tubes. This is the Grail mission. This was performed about 15 years ago. It mapped the surface gravity gradient on the moon. The areas in red are elevated areas of increased gravity, and the blue areas are decreased gravity. And you notice the blue areas have a curvilinear configuration. And these are consistent with intact or collapsed lava tubes. Collapsed lava tubes are the rills that we see on the moon. If you remember the Apollo 15, it was landed near the Hadley rill, and you could see a huge depression there. This was a rill or a collapsed lava tube. So even if a small percentage of these blue curvilinear lines are intact lava tubes, well, they're present all over the surface of the moon. And what I like to think is that this is the future map of the subway system of the moon. We connect the intact lava tubes by tunneling from one to the next, and we can have an underground transportation system on the moon. This is a map of the spread out map of the moon. These highlighted areas are skylights. These are openings in the surface of the moon that indicate that there's a evacuated or a chamber underneath the surface. So in the center here we have Mare Tranquillitatis and Marius Hills were pointed out. This is an example of Mare Tranquillitatis. This is a skylight that you can see there's a chamber underneath. This is about 80 meters in diameter, and I think it's about 60 to 80 meters to the floor below. But there's a large evacuated chamber underneath. The surface looks otherwise unremarkable, but there's a big chamber underneath. This is the target of future exploration. The Grail report stated that the lava tubes that they discovered have very large volumes. They are 2 to 3 kilometers wide, half a kilometer high. They're 20 to 30 to 50 kilometers long. One lava tube is more than 100 kilometers long. So there's significant volume here for placing large facilities. You could put the city of Shanghai in one of these tubes and you wouldn't bump into anybody. There's a lot of room to play with. One of the interesting phenomena of the lava tubes, they were formed by lava flowing on the surface, so they are oriented horizontally. So that's an advantage for, in the future, you want to have a rail system or a road system. You can go from one end of the tube to the other by having just doing what we can do here on Earth with subway systems. We can put in a rail system and have a transportation system. The lava tubes are stable. They've been around for hundreds of millions or even billion years. So they've been tested for their stability. That doesn't mean that they are stable currently. Maybe some of them could collapse, but they have a pretty good record of being intact for a long period of time, and we can take advantage of that. So in other words, lava tubes are fortuitous, ideal geologic structures for human settlement. They offer complete protection against radiation. The cosmic galactic rays cannot penetrate 20 meters of regolith or 50 meters of regolith in the roof of these lava tubes. Absolute protection from micrometeorites. And the mechanism that produces lunar dust, the space weathering on the surface, doesn't occur underground. So we expect there will be no lunar dust in the lava tubes. And the indications are that there's a stable temperature profile in the lava tubes, approximately minus 20 degrees Celsius, although that's not completely known yet. We have to evaluate that further, but a constant temperature is a very favorable variable. So these lava tubes can accommodate large facilities, such as nuclear reactors, greenhouses, manufacturing systems, housing, life support systems, places for recreation and storage. We can do big things on the moon with lava tubes, and they're not perfectly safe, but they avoid all the hazards of the surface. So we can work in the lava tubes and be nicely protected. So the first lunar base is now possible within a selected lava tube. We've been talking about going to the South Polar region. We emphasized this, Madhu and I, in our previous book, going to the South Polar region. But there's an advantage to going to the equatorial regions just from the orbital mechanics of landing and taking off with rockets. So, and the equatorial mid-latitude sites are good for our continuous communication link with the Earth. So we have the enabling conditions for going to setting up a base on the moon. We have the motivation, the technology. We have a safe location, that is the lava tubes, and we can take advantage of international cooperation to make this happen. So to have a first base on the moon, the nations, combination of nations would provide for science projects and resupply. They would provide for governance, have a municipal type of governance or a port authority. And corporations could provide energy, housing, transportation, manufacturing, communication. Now, for the last 70 or 80 years, however long, much time we've been going to the moon, we've had sorties to the moon. We go to the moon, we look around, and we come back. Nothing has been planned for human permanence. With the lava tube, we can now think in terms of no more sorties, or we'll have sorties, but for human expeditions, we're going to have a base on the moon, a permanent place. So if we have international cooperation, all participating nations from around the world can focus all of their energies on one lunar base. And of course, the corporations can provide communications, manufacturing, energy, and food. This would governments could establish an initial lunar economy to provide all of the things necessary for human longevity on the moon. Development steps for this process. We need to explore further the moon for lava tubes. Perhaps this would take 5 to 8 years, maybe 10 years of exploration with gravitometers or ground penetrating radar to define the best lava tube for setting up a permanent base. After a base has been chosen, we can then prep for humans, for the return of humans for a small crew. That would be another 5 to 10 years, perhaps. In the past, we've been thinking about in situ resource utilization, and that's fine, but we don't need to do that for the first base. We can deliver all of our supplies. We can deliver oxygen, we can deliver water, we can deliver nitrogen, and all of our accommodations with our heavy lift rockets. We don't have to use lunar resources at this stage. So we can deliver everything we need for human habitation to the lava tubes and prep things for the return of humans over the next 5 to 8 years after we've identified the lava tube. We can then think in terms of having permanent human crews mid-century. if somebody gets in trouble if you land on the moon and the crew is stuck in the lava tube, say a crew of 5 or 10 people, they could have enough supplies inside the lava tube to last for several months. And it's only a 2-day journey from the Earth to the moon. So we can talk about having human crews on the moon permanently very shortly after we've set up shop in one of the lava tubes. So this is a artist's conception of it being inside of a lava tube. You can see the scaffolding there for construction. We're looking through a skylight. You can see the Earth in background and the stars. Another fanciful description or depiction of an elevator from the skylight down to the base of the lava tube and construction equipment. So for our next stage of going into space and setting up permanent habitation, lunar lava tubes are optimum sites for the human settlement. We no longer are thinking in terms of sorties, we're thinking in terms of human settlement. And we can do all the things that everybody's been talking about in this meeting in terms of the technological aspects of survival and human permanence. So we select a site, develop it into an international settlement. The planet Moon then becomes our second home in space. And once we learn how to do that, we can then replicate that on Mars and then endless frontiers. So that's my conclusion.
No, I liked your idea about lava tubes being like the future subway system. That was very clever.
We can do all the things on the moon that we do on Earth. It's just waiting for us to happen. Thank you for that.
The lava tubes exist on the far side of the moon. Is there any difference between the far and the near side of the moon?
I've looked at the far side. Is much less interesting in terms of human settlement, but it appears that they're much more frequent on the near side of the moon.
They're more frequent on the near side of the moon. Like
yes.
You have like twice as frequent, 3? Do you have any idea?
This is just an anecdotal observation on my part. There's probably 10 times more on the near side for whatever reason.
Okay, good. So do lava tubes exist on Earth?
Lava tubes, I'm sorry?
The lava tubes exist on Earth?
Yes.
They do? Okay, all right, good, thank you. Okay, I appreciate it.
Yeah,
there are some parks where you could even go on a hike through one if you really wanted to in the United States.
Oh,
yes.
Oh yeah?
The big island of Hawaii, I've been through that lava tube, and it's about 15 feet in diameter.
How about the mainland? Are there parks that you can do that?
I don't know of any, but I'm sure there are.
Craters of the Moon National Park has one that you can go on about a 1/3 of a mile hike through.
Where's Craters of the Moon National Park?
In Idaho, actually.
Okay, all right, okay, thank you. That's very interesting. No, lava tubes, yeah, very interesting. Okay, good. Thank you. I'll be quiet now. But
Matt, you have a question as well?
I just had a comment to make that a lot of lava tubes have only been identified on the moon from Earth-based observation of the way that light enters the skylights. And that's why it seems like there are more lava tubes on the near side of the moon, just because we haven't gotten enough eyes on the far side of the moon to verify if they're actually in the same quantities on the far side. Grail, their data being used to identify lava tubes is pretty new, and it's pretty exciting.
It makes human settlement, it speeds up the human settlement question by decades, in my view. I'd like to point out that a couple of lava tubes have been spotted near the polar regions. They're much less frequent, they're much more frequent in the equatorial and mid-latitude areas. But there's 1 or 2 perhaps in the polar regions. For some reason, they're not as frequent there, or there's not as many there. But the thing is, in the polar regions, they might be full of water ice. They might have resources. So if we go to a lava tube in one of the polar regions, we can harvest all the volatiles that are frozen there. But the main thing is in mid-latitude areas, we have the opportunity for large human settlements and absolute protection from not absolute, but significant protection from the hazards of space. It speeds up everything by years, if not decades. The house has been built for us. The frame of the house is built. All we have to do is put in the electrical and the plumbing, and we're in business. And a friend of mine happens to work in the nuclear industry. He said that a 30 megawatt nuclear reactor for the moon would be possible very quickly, and they're even talking about a 1 gigawatt nuclear reactor for use on the moon if necessary. And the second thing is that when you have a nuclear reactor, you have the situation of waste heat. Well, if we were to go to the South Polar region with a nuclear reactor, the waste heat could be used to help recover the ice deposits that are in the South Polar region without mechanically removing the lunar regolith. You could just put underground pipes and recover the vapors that come off using the heat from the nuclear reactor. So we have a lot of tools, and we know how to use these tools. We can sustain life. We have a large space. We're absolutely protected.
Frank, do you have a very quick question? We are over time a bit, but I think the next speaker will be lenient.
Yes, real quick, I was wondering if the Lunar Reconnaissance Orbiter was equipped to look into permanently shadowed area, as far as people know, and it seems that on Earth, like volcanic activity seems to be like concentrated around the equator because there's a matter of temperature differential in this equation. I don't know if that model translates to the moon, but yeah, any comments on the polar lava tubes?
The Lunar Reconnaissance Orbiter has identified something like 270 skylights that open into lava tubes. They haven't found any in the polar regions. There's maybe one in the South Polar region for whatever reason. They're just not they're not that frequent in the polar regions. Unfortunately, that'd be a good place for getting volatiles recovered. So the answer is the lava tubes tend to be in the equatorial and mid-latitude areas, and there's a lot of them that have been identified, but nothing in the polar regions. Definitely we want to go to the polar regions, but we don't have to do that right away because we can bring in all of our supplies with our starships and so on.
So it's not our scanning tools are deficient, it's really like the lack of presence of them on the sites.
Well, we need further exploration, and maybe we'll find some lava tubes in the South Polar region. That'd be a marvelous discovery.